Hi everyone, my name is Chris, and this is my AppArmor and HTTPS presentation. Let's get started. So AppArmor is a Linux security module that restricts applications' capabilities and permissions. It is installed and loaded by default in the Ubuntu OS. You can check the status of it with the AA status command. It uses profiles that are set per program. It also provides mandatory access control, which is a security strategy that restricts the individual resource owner's ability to grant or deny access to resource objects in a file system. This supplements traditional Unix model of discretionary access control, where the object owner determines the access policy. AppArmor profiles are a set of rules or policies used to determine what files and permissions the application requires. With this, you can control what resources an application can access, such as files and interfaces. Profiles have two modes of operation: complaining or learning mode, which allows the profile to perform unauthorized actions, and it just logs them. This is useful for development and testing. And then you have enforced or confined mode. This is where the profile's policy is enforced and violations are logged. It's the setting the profiles will be in most of the time, unless you're editing them. So profiles are listed in the .d directory. An example of this is the profile for the ping command is here. And this directory also stores abstractions. These are reusable sets of rules that can be included in multiple profiles. This is useful for applications with common security policies, and it does away with the need to repeatedly define the same permissions for applications. Some common commands include the AppArmor status command, which is used to check the status and number of loaded AppArmor profiles and shows their status, which is either enforced, complain, or unconfined. Unconfined profiles are unrestricted by AppArmor and have full system access. The AA complain command places a profile into complain mode, and the AA enforce command places a profile into enforce mode. The AppArmor parser command is used to load a profile into the kernel. It can also be used to reload a profile using the -R option after editing it for the changes to take effect. So when enabling or disabling profiles, AppArmor includes predefined profiles for common applications. These can be customized or used with their default settings. Other profiles need to be copied to the .d directory and set to complain or enforce mode. Many profiles are not up to date and will require debugging when set to enforce mode. To disable a profile, symbolically link it to the -disable directory and use the AppArmor parser -R option. And to re-enable a disabled profile, you remove the symbolic link in the /disable directory, then load the profile using the -A option. Some hardening techniques. To successfully deploy AppArmor, you should first consider the applications to profile and build new profiles as needed. Also, make sure you update your profiles whenever your environment changes or when you need to react to security events. Programs are exposed to attacks and your specific system need to be profiled. When determining what applications these include, consider if they are network agents, web applications, or cron jobs. These perform regularly scheduled actions such as backups and report generations. After creating a new profile, run the full range of the application's actions by performing every task you need with it. If you notice any abnormalities, check the system logs to see if AppArmor is too tightly confining the application. Also, let AppArmor analyze the log files using the AA ginprof command. AppArmor will ask you to set the access rights for each event logged, and you can set them individually or use globbing, which is useful for applying security policies to groups of files and directories. Alright, so let's talk about HTTPS. But first, let's figure out what the difference is between HTTP and HTTPS. They both serve the same purpose, to transfer information over the internet. Web pages are stored on servers and provided to the client's computer when a user accesses them. This link between servers and clients creates the World Wide Web. HTTP simply fetches information from web servers with no added security. All the data is in plain text and unencrypted. HTTPS has an added SSL/TLS layer that ensures all data being transferred is encrypted and secure. The default HTTP and HTTPS ports for the web server are port 80 and 443 respectively. And web ports are numerical identifiers for each service or application. They're used to direct data to the service or application being used. So the HTTPS protocol uses the Transport Layer Security Protocol to encrypt communications. TSL secures communications by using asymmetric key infrastructure. This uses two different keys to encrypt communications between parties. The private key is controlled by the owner of a website and is kept private. It is stored on a web server and used to decrypt information encrypted by the public key. And the public key is available to any client that wishes to interact with the server. Info encrypted by the public key can only be decrypted by the private key. HTTPS uses TLS encryption over the HTTP protocol. It occurs based on the transmission of TLS certificates, which verify that the provider is authentic. When a client connects to a web page, the web page will send over its certificate, which contains the public key. The two computers then go through a process called the TLS handshake to establish a secure connection. The steps of this will vary depending on the key exchange algorithm used and cipher suites supported by both sides. During this process, the client and server specify which version of TLS they will use. They decide on which cipher suites they will use. They'll verify the identity of the server with the server's public key and the SSL certificate authority's digital signature. They'll also generate session keys to use symmetric encryption to transmit data after the session is complete. Alright, so IIS. This is a Microsoft web server that runs on Windows systems. It serves requested HTML pages or files. And it works through many different standard languages and protocols, like HTML, HTTP, HTTPS, File Transfer Protocol, or the Simple Mail Transfer Protocol. So when configuring HTTPS on IIS, there are several steps involved, starting with obtaining an SSL certificate and configuring IIS to use it. So first you need to generate a certificate signing request. This can be done on the IIS manager. After you have filled this out, submit the CSR to a certificate authority. And when you receive it, go back to the IIS manager, click the complete service request, and select the certificate file. Once you have the SSL certificate, you need to bind it to your website. So in the IIS manager, select the site you want to secure with HTTPS. In the bindings dialog box, add it to the appropriate IP address. Make sure you enter 443 for the port and select the SSL certificate you imported. You also need to ensure port 443 is open on your firewall to allow HTTPS traffic. Some hardening techniques for hardening the IIS server and when configuring HTTPS include configure firewalls to ensure the server is only receiving valid packets. You should use logging to view the visitors accessing the web server. Require SSL when configuring its settings in the IIS manager. And redirect HTTP to HTTPS. All right, so Apache. It's an open source HTTP server for operating systems including Unix and Windows. The process is not very different from IIS, however, everything is done over the command line. So when you generate a private key on your server, you then generate the CSR using the private key and submit it to the certificate authority. After installing the certificate and private key in a secure directory on your server, enable the SSL module. Next, edit the default SSL configuration file to specify your SSL certificate, key, and intermediate certificate. Lastly, enable the SSL site configuration. So, some hardening techniques with the Apache server and configuring HTTPS include redirecting HTTP to HTTPS by editing the HTTP virtual host configuration. In the Apache configuration file, add the following lines. You can also hide Apache version and OS information. By default, Apache displays its version in case you browse the wrong URL of a website. This could be useful information for hackers. You can also disable directory listings. By default, Apache allows directory listings, and visitors might see whatever files or directories you might have on your document root directory. All right, everyone. Well, thanks for listening to my presentation.